Welcome to day 3. We're going to talk about methods of heat transfer. This is definitely a review. You've been talking about this since junior high and probably in elementary school. So we're going to go through it pretty fast. Most of it's just reading and reminding yourself of things you've already known. First thing we're going to do is talk about conduction. And we know conduction involves physical contact. So if you want to conduct um, heat into your pan needs to be touching the fire or the heat source in order to do that. So they have to be in contact. And the example here is dipping your spoon into ice cream. The spoon eventually will get cool as your heat from your hand will be keep going into the ice cream and causing it to melt. Conductors are things that, of course, can conduct this energy, and they readily transfer it from one location to another. And the reason metals are so good is because of the electrons that are loosely bound, and they're able to transport that energy very, very rapidly. Poor conductors, on the other hand, are called insulators, and these do not transport the energy very effectively, and so we can use them to insulate. And so things like styrofoam and wood's a pretty good insulator, things that are going to stop that transfer. The next one is convection. Convection involves a fluid, and this is probably the one that, unless you're really thinking about what the word means, people forget that it works both with liquids and with um, gases, because those are both fluids. And so as long as you think that both fluids can be liquids or gases, you'll remember all of this. Inside of the pot, at the top of this diagram, you can see that at the bottom, through conduction, the heat is transferred into the material in the pot, which is the liquid. As it heats up, it expands and rises and has less density. It will then cool and condense and fall down, and you get convection currents. This also happens in stars and our sun. It happens in our atmosphere, and that's the next one down. You can see that warm air rises, and as it rises, then it's going to cool and condense, and then it will fall down. And you've studied the water cycle, and that you dealt with that when you were doing the water cycle. You can also explain why you have sea breeze, and if you are during the day, the water is cooler than the land, and so the air over land will heat up, and then it will rise until it goes high in the atmosphere, where it cools off, condenses, and falls down, and it will just continue to do this cycle. And then the opposite is going to occur. At night, the land will lose that energy, and so it will start condensing the air over the land, and it will be going out over the water and expanding and rising, and it forms these convection currents. Again, you've seen all of these. Radiation is the electromagnetic waves as they travel, and anyone that has had a sunburn, you know that it can be real strong radiation from the sun, which is very far away. Radiation is also how you feel a bonfire or a wood stove, like we saw a couple days ago on that podcast. And we're going to really study these waves in great detail in our next unit, but just be aware that how do you transfer this energy in thermodynamics, and one of the ways is going to be radiation. Examples would be light and microwaves and radio waves and x-rays. And the wavelength is related to the frequency. And the higher the wavelength, the higher the frequency, the shorter the wavelength. And if you think about it, as pitch goes up, you've watched it probably on the sound mixers. If you've seen it on any of the programs you can get on your computer, and you'll see as the pitch goes up, the frequency increases and the wavelength goes down. Same thing goes with light, and we'll study those again a lot in our near future. Every object does radiate electromagnetic waves, and depending on the amount of energy that it's going to transmit will determine the kind of wave that it has. And people with night vision goggles, if you watch movies or if you've ever used them, you can look in different frequencies. If we aid our eyes, we can only see it in the visible spectrum, but we have things that can translate invisible to our eyes spectra, and so that we can see it. Things absorb radiation, and we know that has to be the case because we've got to conserve it somehow. So radiation can be conserved by transforming it into something else, and good emitters are good absorbers. So that's something that we will again get more into later. Diffraction grating, when we looked at the lights in those tubes that we looked at in class and we saw that it breaks it down into patterns, we can also pass that light through gases that will do the same thing, and it gives us the negative of that, and you can see those are good absorbers. Radiation you've dealt with the greenhouse effect in your car. The sunlight comes in and it is turned to infrared, which can't escape the glass, and so it gets warmer and warmer and warmer inside your car as the heat is trapped. Good absorbers are going to reflect very little of the energy, and that's why it's good to wear dark clothes if it's really cold outside, or light clothes if it is hot, because then you can reflect that energy. And you've seen the astronaut suits, not only do they have the light color, but they also have the insulation with the gold on their helmets, which is going to help to reflect a lot of that energy that's coming in so that it's not going to do damage to them. We will talk some about Newton's laws of cooling, and the rate of cooling is proportional to the temperature difference between the two objects. So if you want to cool something fast, you will put it on a surface that has a bigger differential, and so you can get that flow of energy going. We don't want to have something cool on something that is hot because it's going to slow that down, even if it's not as hot as the thing we're trying to cool. And so you do have to be aware of that. So why does weather forecaster tell you to cover your flowers when it's below freezing? Well, hopefully you can think about that, and hopefully we'll talk about it in class. So these are good things that we will think about it. But what could be going on underneath that covering? And I'll ask you that tomorrow. What advantage then would it be to wear loose clothing in the desert? What color should you wear if it's arid outside? Kind of an interesting question. And explain why freeze, when we think it's going to freeze, why they will have open those signs up that tell you that there might be ice on the bridge, even though there won't be ice on the ground. So we'll talk about that tomorrow. Hopefully this made sense and reminded you of some stuff that you might have forgotten. And we will talk soon. Y'all have a good evening.